So this is the limit that we are looking at today. It's the limit as theta goes to 0, if sine of theta over theta is equal to 1. The idea is if the angle is equal to the denominator and the angle is going off to 0, you're going to get a limit equal to 1. So you can see in this problem over here we have a sine of 5x. The problem is we don't have a 5x in the denominator, so we've got to be able to get a 5x down there. The way we do that is to multiply by 1, but in this case we're going to write 1 as 5 divided by 5. Multiplying by 1 does not change the value of it. It'll change the way it looks, but it doesn't change the value of it. So we're going to use that to our advantage. We're going to take this 3 on the outside because we don't want it there. We're going to replace it with the 5 here. And this 5 on top, we really don't need it except to make sure that we're multiplying by 1. We're going to take that on the outside as well. What we end up with is 5/3 times the limit. Because we have a 5x and a 5x, this limit is going to be equal to 1, and we get a value for the entire limit to be equal to 5/3. And one thing I do want to point out, it's common to think you could take sine of 5x and somehow bring that 5 on the outside as if you're factoring it. And you can't do that. It's just not something that can be done. This 5 here controls the amplitude. Of course, the amplitude of this one here is 1. You can't have something with an amplitude of 5 equal to something with an amplitude of 1. This problem here, what we've got sine of x plus 3. And again, we cannot distribute it. We cannot get sine of x plus the sine of 3. Nothing like that. It's just the sine of x plus 3. But what we can do is take this denominator here and be able to write it in factored form. X plus 3 is a factor for it. And again, this is going to be about rearranging it so we get the sine of an angle divided by an angle, which is exactly what we have here. This is going to go off to 1. X plus 5, the x is going to become a -3, and we get a value of 1/2 out of it in total. But I do want to say something. We need to be careful because this is not saying that the angle is going to 0. Of course, the angle is x plus 3, and x going to -3 is the equivalent of x plus 3 going to 0. Those are the same things, so we can apply this limit that we're using right here. For this next problem, this is going to be the issue right here. We've got an x squared. We don't have an x squared in the denominator. And if you've noticed the pattern here, we might think that the pattern is 4/3 is going to be the answer. But it's not going to be the answer in this case because we have an x squared here and we have an x. It's actually going to change it. To get a 4x squared in the denominator, we're going to multiply by 4x divided by 4x. Again, it's multiplying by 1, which doesn't change the value. It doesn't change the value out of it, but what it does is give us the ability to change the form of it into a form that we can use. We're going to take this x, multiply by that x. That's going to give us the x squared. We're going to take this 3, move it outside the limit, which you can do because it's a constant. The 4 we're going to take and we're going to replace that 3 right there. And I want to be very careful about what we do with this. The 4 we can take on the outside because it's a constant. The x, we cannot take it out because the limit is dependent upon x. Therefore, we can't separate the two. So what we do is we've got the 4/3 on the outside. The x is just going to have to stay inside, but the limit of x as x goes to 0 is equal to 0. So we know what that is. This limit, because we have 4x squared and 4x squared, is going to be equal to 1. So we get 4/3 times 0 times 1, so we do get a value of 0 out of it. So for this problem, the key is going to be that we have a sine divided by a sine. And we're going to use this right here, as we have, but we're also going to end up using the limit as theta goes to 0. We're going to flip it. We're going to do theta divided by sine. That limit is also equal to 1. So what we do, we're going to end up separating these two. We're going to have a sine of 5x that we want divided by 5x. We've got a sine of 3x in the denominator. We're going to want a 3x in the numerator here. And then we'll be able to take the limit using both of these. So here's what we do. We multiply by 5/5, 3/3, and x over x. We're going to take and we're going to combine the 3x into the numerator because we have a 3x in the denominator. We're going to take and combine 5 and x in the denominator because we have a 5x in the numerator. The 5 we're going to bring outside, and the extra 3 we're going to bring outside. We end up with 5/3. The limit of 3x over sine of 3x, because we have 3x and 3x, that limit's equal to 1. Sine of 5x over 5x, that limit's equal to 1. And we get a total limit of 5/3 out of it. So even though it wasn't of the form sine of an angle over something else, we can still introduce it so that we can use this limit. Tangent's another great example here because tangent is something that you can write in terms of sine and cosine. So that's what we end up doing. We end up writing it as sine over cosine. We want to take the sine of 5x, be able to divide it by 5x. We've already got the x there, so the first thing we do is we split it up. Sine of 5x over x, 1 over the cosine of 5x, multiply by 5 over 5, so we can put the 5 with the x and bring this 5 on the outside. Then we can take the limit of each separately. We've got that limit equal to 1. Cosine of 5x, if I let x be equal to 0, you're going to do the cosine of 0. Cosine of 0 is equal to 1. So we get that equal to 1. We get an ultimate limit of 5 out of it. And one more type of problem we're going to do, and that's using this limit here, where we have the limit as x goes to 0 of cosine of x minus 1 over x. That limit is equal to 0. So we might get a problem like this out of it, where we've got cosine squared of theta minus 1 that can be factored. Then all we've got to do, we're going to change it so that we got that matched up. That limit is going to be equal to 0. Cosine of theta is equal to 1 as theta goes to 0. So we end up with 0 times 2, which is going to be equal to 0. So hopefully that gives you a more comprehensive view of how we can use some very simple limits, such as this limit here, and more importantly, this limit right here.